Ba-ba. Good morning. Good morning, everyone. You guys are on time on Instagram. So we're running dual streams today, YouTube and Instagram simultaneously. Plus, you're going to hear my text thing dinging here. Let me see if I can kill that. Probably it'll still make noise. Hey, Chris. So yeah, just an experiment today. YouTube plus Instagram. We'll see if anybody takes advantage of it, and if anybody likes it, or if it's a complete waste of time. But we'll see what happens. Hey, good morning, good morning. Some new faces today. Yeah, I really oughta. So let's see if Jake joins us today. I could bug him about our new razor. That's really funny. So, hey, there's tech support. Welcome aboard, tech support. Yeah, I wish on the YouTube side I could just have like a window of everybody who is currently watching. You are everywhere. I know. That's why I asked you to be air traffic control, because you're up in the tower. Sorry for the dinging. So we're in the shop today working on PFG Stones. I got a bazillion orders to fill. That's happening successfully. I've posted some pictures of some stuff. You know, you can pop out the window. Pop out the window. Pop out the window. I have no idea what you just said. I don't know. I do not know what you just said. Sorry. Yeah, I got my training wheels on here for some of this. Anyhow, the other thing I have to solve is I know one camera's here and the other camera's here, and I've got to come up with a way to hang the iPad on the screen. I don't think I can do an Instagram Live. Uh-oh. I don't think I could do an Instagram Live from anything but a handheld device. And if I could solve that, I will. Here comes tech support.
Tech support.
Good morning, Adam. How are you? So we're getting rain from the hurricane. Here's tech support. Hello. Tech support. What are you going to show me?
So, top chat. Pop out chat.
Oh, that's not what I meant, but okay. That's fine. No, what I wanted was, I wonder if it'll tell me who's top chat, live chat. We'll leave it on live chat for the moment.
Yeah. So,
okay.
I don't believe, unless you were to, watch your Instagram Live.
Hey, thanks.
From your computer, which in theory you can do, because you can link.
Look what Chris says. Chris, you know you're going to lose your mind if you try to watch both at once, if any.
So, you can connect your Mac to the iPad. You can connect them as monitors. So,
okay.
That's something to try for later.
Good morning, Chuck, from California.
Anyway, I'm going back to my tech support station.
Okay, go.
We have snacks there.
We're good. This is good. This is all going to work. Everybody's going to...
This is fine. Everything's fine. Nothing's on fire yet.
So if you're watching on YouTube, you can ask questions in the chat. I have that live. And, oh yeah, that's right. Okay, so Chris points out that the picture you see on Instagram is mirrored, and the picture you see on YouTube is not mirrored. That's pretty cool. Hey, bienvenido. Mexico is with us. So, where were we? So, good morning. I'm in southern New Hampshire. We're getting pelted by... hey, no problem, Chuck. I get that a lot. Chuck said, I will be in the background as he's puttering around the shop, which is totally normal. Good morning, Dan. How are you? Dan, you got any rain today? Any rain? So, yeah, we have a steady medium rain right now. And I think we're going to have that for the next 24 hours. I don't know. Just a drop. Yeah, you could have some of my drops. So, the biggest news from the shop this week. Yeah. Chuck, if you want, I will FedEx you some rain, okay? Welcome aboard, some new guys. Henri, yes. No, we will be happy to put Henri on a bus and send it to you. Buenos dias. Encantado. Yeah, I get to use some of my bad Spanish. CNC built. Good morning. See, everybody is like much more on time now. I'm very happy about that. So we can all get into the room, get the job done, and get out. And nobody is on YouTube. So that tells you what that was worth. We'll see what happens later. So biggest news from the shop is that PFG Stone production is back to production levels on the new grinder, and it is awesome. So that's really nice. I'm able to walk away from the machine for between 20 and 30 minutes, actually between about 34 minutes at a time, and that is huge because I can now go do some other things. So it has caused me to parallel up my tasks, which I can't tell you how good that is. So that's neat. The Okamoto is just rocking it. I will post more photos as we have some cool photos. But it's just making work happen, and that is just awesome. So all the major machines. Dan, I am the automation. Yeah, no, I hear you. I don't know if I could teach a robot how to drink tea though. That's hard. Speaking of tea, I got to show off my my T-shirt that was made for me by Roy Crumrine and his family, and it tells my whole story here. Tea, antennasis, sleep, repeat. There you go. Warren, good morning. So, yeah, automation is something I haven't... Well, this is automation. I mean, we don't have any robots, but the fact that I have a CNC machine in the grinding department now is just utterly fantastic. So I can't be happier. So I posted a picture about an hour ago, I think, of the PFG Stone Effluent, which we have correctly named NFG. Tech support is on YouTube. Thank you. And the automatic filter paper feeder on the coolant filter tank, the coolant tank and filter combination. I'm kind of messing with it a little bit. I want it to trigger a little earlier than it's triggering. So it's like if you look in your toilet, not that part of the toilet, the tank. You know how you have a You have an arm with a float, and when the water comes up, it lifts the float and turns off the valve, commonly called a float valve. The filter coolant tank has the same thing. So when the filter paper is on a conveyor, which is U-shaped, and it goes through a little dip, so it kind of makes a bowl out of the filter paper, and then if it clogs up, the coolant level starts rising, and it raises a float, which triggers the filter paper to move on the conveyor belt. I kind of want it to trigger a little more than it has triggered, which is not at all. I had to manually trigger it. Probably I'm being a little premature about it, but I want it to be more sensitive right now, and I could always turn it down. So I've been messing around with unscrewing that float and things and stuff, but I can get through production this week. But that's sort of the next shop project is to figure that out. So everything's working. I can't complain. The rain, the storm, the hurricane has a risk of causing a power outage. I'm kind of keeping an eye on that. I don't think anything is going to get damaged if I lose power, as far as the grinder is concerned, but it sure will be inconvenient. So that's what's going on in the grinder department. 3D printer department. I've got a report on 3D printers. If you've been following me, my friend up in my friend up in York, Maine, which is north of me, an hour's driveway to driveway, so not terribly far away. He just reported heavy rain started suddenly. So it's made it to Maine. Action Van, good morning. So, yeah, 3D printer department. We had a Prusa and we had a Lulzbot Taz 6, and they were making our trays. They were making our trays for our PFG Stones. This is an experimental set of PFG Stones. And from day one, they've been cranking them out. So the Lulzbot was set up with a big nozzle. So we set that up with a 0.8. Yeah, roger that, Dan. we had a 0.8 millimeter nozzle in the Lulzbot, which was suggested to me wisely by Eddie Reese from Saunders Machine Works, and it was able to print these trays, pretty fast and very high quality. And then we had a Prusa, which has a 0.4 millimeter nozzle, and that was my setup for many, many, many months. And then I decided I wanted to improve things. Hey, Craig Camp. So what I did is, well, let me explain. The Lulzbot used 3 millimeter filament. The Prusa uses 1.75 millimeter filament. So I had two kinds of filaments in stock. So that was making me inefficient. So I decided I'm going to sell the Lulzbot. The reason I didn't sell it, switch over until now, is I thought that my 8-inch trays. Hey, Grandmaster Bob. Good morning. We're talking shop here, so I hope we don't bore you. The 8-inch trays I feared didn't fit on the Prusa. Let me grab one. Hang on. So there's an 8-inch tray, and it's a big boy. And it turned out I was completely wrong. It turned out that the Prusa is wider in X than it is in Y, and I am able to print an 8-inch tray. In fact, this is a Prusa printed 8-inch tray, and it's pretty gorgeous. So as soon as I figured out that the Prusa can handle my 8-inch tray, that was the trigger, and out went the Lulzbot. You'll take 22? Yes, sir. I'll have them for you by Wednesday. Although I didn't say which Wednesday. So, anyway, yeah, so I'm going all Prusa, number one. That means I'm going all 1.75 millimeter filament. That improves efficiency. I don't have to think about stocking multiple filament diameters. And I bought a second Prusa, and I posted a picture of that. And some of you wisely pointed out that there was more room on that table. So, Machine Shop 10 EE, welcome. I bet you're getting rained on, right? So I bet, in fact, I think you might get more rain than I. Anyway, so some of you commented that the table that the two Prusas were sitting on had this empty space to the left. I have a confession to make. There's a third Prusa coming. So, oh, are you? Okay. You're probably still getting rain. 10 EE is in upstate New York. So the third Prusa is on the way. It's going to be another kit, so I'm going to build it again. I kind of like building them because you get to see what's going on. All right, Craig Camp, take care, buddy. So yeah, we'll have a 3 Prusa farm, and that'll be our setup. We're donating our Lulzbot to the Story School, which Conjet, also known as Tech Support, has been interning with, and they're setting up a makerspace. So it turned out that they valued getting a 3D printer, so we're making that a donation, and that's pretty cool. There's a link in the chat if you're interested, the Story School Adventures. All right, Dan, see you later. Take care, buddy. Thanks for checking in. So that's what's happening in the 3D printer department. It's pretty exciting, and it makes it a better tool. I could walk downstairs, start a print, and even if tray production is going on, I probably can squeeze something in because of the 3 printers. Or if I get a big order, 3 printers increases my throughput, and that is a big deal. So we did get a big order. A couple of days ago, we got a big order from, I'm not going to say who, but because I don't have permission. And it was a big order. So the fact that we can crank out trays quickly, the fact that I can, my process allows me to walk away from the machine, all good. So PFG Stone production is winning. Octane, welcome aboard. So now that Octane is here, we're going to knock less. Knock less. All right, yeah. 3 of us got that. Okay. Questions. You guys have any questions? Use the use the question button. Yeah. And we'll answer some questions this morning. It's the best I can do, Chris. It's early. It's raining. So my wife made cinnamon sticks this morning, so I had some cinnamon sticks, I confess. Oh, there is a question that was asked last week. And gosh, I'm trying to remember who asked it. Yeah, no, I assure you, this tea is not unleaded, or this day would not be underway. So there was a question asked a couple of weeks ago about truing diamond wheels. And we could talk a little bit about truing diamond wheels. So let's not forget that question. Tech support wants you to know that the question box is on the bottom of your screen. By the way, tech support, well, I think you already know this. We have no takers on YouTube, so that was we'll still do it again next week. So, do you guys want to talk about truing a diamond wheel? I'll go get some props, but I need to know that you guys care, because if you don't care, we'll leave it for a day when there's somebody that cares, and we could talk about that. Anybody? Diamond wheels? Truing diamond wheels? Bueller? I did not turn the stream off. The stream is running. Chuck says sure. Warren says sure. Okay, let's address this one first, and then we'll talk about truing diamond wheels. Can you use CBN for grinding stones? Actually, we're all nodding. You're all nodding off is what you're doing. So early on, yeah. 10EE says this is the most you'll get from students. It's okay, I get it. Can you use CBN for grinding stones? The answer is probably yes. I experimented with CBN early in the process. The problem was I didn't do a good job experimenting, so I don't have really good results from it, and then I just stuck to diamond. CBN has its place, and for those of you who are not into grinding, CBN stands for cubic boron nitride, and that's yet another hard abrasive that is not quite as hard as diamond, but it's harder than silicon carbide. Yeah, so the answer is I don't know. That's the summary statement, is I don't know about using CBN on stones. I think you can. I don't. And I don't have enough information about that. So I've been thinking about this a lot. If I had to 10EE, you are completely correct. Diamond wheels and steel do not mix. So let me address that right now. What is a diamond made out of? It's carbon. It's a crystal of carbon, pure carbon. That's what a diamond is. So the problem is that steel likes to have carbon dumped into it. It will. Let me put it a different way. There's a word that I'm not remembering from chemistry, but carbon dissolves into steel. So if you use diamond on steel and it gets hot enough, the carbon from the diamonds will literally dissolve into the steel. And the result is the diamonds will be ripped out of the wheel and is no good. No good. Your wallet will be lighter. But that's the only thing that'll happen. So you can't use diamond wheels on steel. CBN is not diamond, and you can use CBN on steel. So it is diamond-like in that it's a super abrasive. It's very hard. So that's why CBN has a place in grinding steel, is because diamond can't. So if you're doing hardened steels and you're doing some precision grinding and you want to get, maybe you're dealing with super hard materials or you're dealing with some super precision, not sure, but you can choose to use CBN. And CBN does grind steel. But diamonds, not happy with steel. All right? So let me go grab, I'm going to go grab a couple of props, and we'll talk a little bit about truing a diamond wheel and some of the lessons that I've learned. So please stand by. I'll be right back. Okay, so this there we go. This is a resin bonded diamond wheel. Okay, 100% concentration, max RPM 5100 RPM. It's an 1/8 of an inch thick, and there's your designator. So it's 1A1 7X 1/2 MCC. So anyway, it's a 1A1 wheel. Just means it's a straight wheel. Okay. This wheel is mounted with a Sopco 200 adapter. Okay. Then we add a Kinetic Precision B200 balancing ring. So we're able to balance this wheel. Now, this is a wheel that I purchased off of McMaster Car. So this is easy to get. This is aluminum. This is an aluminum hub. Aluminum hub. And you'll notice there are no drill holes in the aluminum hub. So this was not balanced at the factory after being manufactured. So we balance it. We always balance it anyway. But we balance it with this balancing ring, the B200, available at Kinetic Precision. Okay, so this comes in, and we say, "Hey, we're ready to use this." No, you're not ready to use this. So you first mount it on the hub, and you can argue whether or not you balance it before you do anything else. If balancing is quick and easy, you balance it. Then you take this over to the grinder, and now we're going to true it, just like we true any grinding wheel. Trouble is, what is this? This is diamonds in a resin, right? So it's a very hard thing being held by a very squishy thing. So how are we going to true that? Now, if we had a regular grinding wheel, we would use a diamond and the aluminum oxide, which is the same thing that PFG Stones are made out of. The aluminum oxide is softer than the diamond, and our diamond will cut the aluminum oxide. So that's easy. Well, what cuts diamonds in resin? If you use the diamond nib, you'd have diamond on diamond, no good. Okay, just like any other tooling situation. So what we do is we get clever. So before I talk about the methods we use, let's do a quick thought experiment. And in this thought experiment, we're going to take you're going to stand there with a baseball bat, okay, or for our international visitors, a cricket bat, okay, and I'm going to take a 1/2 inch ball bearing, okay, or bearing ball. I'm going to take a 1/2-inch bearing ball, and I'm going to underhand that 1/2-inch bearing ball to you. Are you able to hit that bearing ball with that baseball bat or cricket bat? The answer is, of course, yes. In fact, you could smack that thing, 100 feet, no problem. Next part of our thought experiment. You're going to stand there with your baseball bat and or cricket bat out of the park. Yes, I would hope so. 10EE is going to smack a homer with the 1/2-inch bearing ball. So now let's same setup. You're at home plate and you've got your baseball bat, and I think Chuck. I'm picturing Chuck is giving me signs of what to pitch with this bearing ball. Much respect, Chuck. So now I'm going to load this into an air gun, and I'm going to fire that 1/2-inch ball bearing at your bat at 200 miles an hour. Are you going to be able to hit that bearing ball out of the park? Or is that bearing ball going through your bat? What do you think? Anybody? Bueller? Which is going to happen? You hitting it out of the park, or is it going through your bat? I hate this delay. This must be what it's like doing a tutorial on Mars. KR Blodgett says, through the bat. Conjet.art says, bye-bye bat. Who's next? We need one more vote before we reveal the truth. Does anybody think that you're going to be smacking that half-inch bearing ball out of the park? So the truth is, no, it's going right through the bat. Okay? You're not, yeah, well, Chris is going to knock it out of the park. So at some velocity, I'm just going to fire that ball right through your bat. Okay? So we have these two conditions. I underhanded you a bearing ball and you smacked it out of the park, or I fired that bearing ball at you at high velocity and it went through your bat. And Warren Jones says, and I'm quoting now, I'm not paying attention. What is the question? So now, let's move on. So now you've got a diamond. You've got a diamond being held in resin. Okay, this is the equivalent of a golf ball on a tee. So is the tee strong? The tee is not strong. Not this tee, the golf tee, but the golf ball is strong. So we're coming around, and the bat is going to try to knock the diamond out. So let's talk about what the bat is. The bat is a piece of aluminum oxide. Okay? Or aluminum oxide. Or I need one more. Hey, Mary Tool. I need one more prop. I'll be right back. So this is aluminum oxide. This is called the dressing stick. We'll talk about what this is for. But here's your bat. And here's your ball. Okay? So the diamond comes along and it hits the aluminum oxide, and it's going 7,000 surface feet per minute. 7,000 surface feet per minute, and it hits that aluminum oxide. Is the ball bearing going through the bat? The ball bearing is going through the bat. So all you end up doing is grinding the aluminum oxide. So what do? Let's slow this guy down. This is the equivalent of me underhanding that bearing ball to you and you being able to smack it with the bat. If we slow this guy down and we jam him into this aluminum oxide, I will start knocking diamonds out of the resin. The resin is cream cheese. Okay? I am knocking diamonds out of the cream cheese. I think we need that on a t-shirt. Knock the diamonds out of the cream cheese, okay? So, intuitively, there's a way to true this guy up by knocking the diamonds out, not by trying to cut them. So, this brings up two things. One is the famous, see if I can get, Norton brake-controlled truing device. So the Norton brake-controlled truing device is pretty cool. This goes down on the table. Okay. And we're going to run our diamond wheel on this aluminum oxide wheel, like so. And we're going to run at full speed. So 3,600 RPM is a typical grinder speed. I see a couple of questions coming in. I'm going to get to them. And then we're going to bring the wheel down right onto this thing, and this thing spins. And I want you to think about that for a second while I check the questions. Pragmatic asks, how thick is the diamond material on the wheel? 1/8 of an inch. In fact, it's that brown stuff is the mixture of diamonds and resin. It's 1/8 of an inch thick, and if you look at the wheel, it tells you it's 1/8 of an inch thick, right there. That's a 1/2 inch width. Okay, so the way the diamond dresser works is when your diamond wheel comes down and touches this wheel, it starts spinning. But back here is a centrifugal brake. 3 bronze shoes that are on springs, and they fly out and they touch the inside of this cylinder and they put the brakes on. So this thing will limit to a certain RPM, and then the brakes go on. And what that does is it reduces the surface feet per minute that the wheel sees from about 7,000 surface feet per minute, thereabouts, it might be 5,000, I don't remember, down to about 1,200 surface feet per minute, thereabouts. And now the aluminum oxide, the relative speed of the aluminum oxide and the diamond wheel is slow enough that the aluminum oxide starts acting like the baseball bat hitting the bearing ball that I tossed at you, and it starts knocking diamonds out of the matrix, which is made of cream cheese. Okay? Do you got it? I want to make sure that concept got across. So that's how you take a material that's hard, but not harder than diamond, and you use it to true a diamond wheel. This is the bat. This is the bearing balls. If they're going slow enough relative to each other, you will be able to knock them out. If it goes too slow, it doesn't have the energy to do the job, and if it goes too fast, the diamonds just start cutting the aluminum oxide. So that is why you're able to use a device like this, okay, the Norton brake-controlled truing device. That's its actual name, by the way. This is a Model 1. It's pretty classy. I cleaned it up. Do you move the dresser in and out? Good question, Chuck. It only knocks the high diamonds out and leaves the rest. Yeah, you move down maybe 0.02 of an inch on the wheel, and it will knock, it will level the playing field. Do you have the wheel spinning at normal speed? The answer is yes. This is with the wheel at normal grinding speed. I'll explain why. Hang on, guys. Chuck says, do you move the dresser in and out to keep the dresser wheel flat? Well, the dresser wheel is spinning, right? So you come in with your wheel, and yeah, you make passes on the wheel, okay? And it's maybe a little better to never actually completely lose touch with the wheel, but yeah, you traverse across this guy as it's spinning, and that's how that works. This is a consumable. This is a big consumable. This thing is small compared to new. Okay. Let me grab a new one. One more prop. Hang on. All right, so there's a brand new wheel, and there's what's on my dresser right now. So this is a consumable, and one thing you got to get used to in the wacky world of grinding is that grinding wheels are like paper towels. Okay, it's not like I passed this grinding wheel on. You know, I got this from my great grandfather, and my grandfather gave it to my father, and my father gave it to me. Would you do that with a roll of toilet paper? I don't think so. So this is a consumable. You use it up. Okay? Anyway. That's how you take a resin bond diamond wheel and a Norton brake dresser. There's other brands, by the way. And that will true this wheel. Now, it's really aluminum oxide. So this wheel, 10EE asked the question, this wheel is straight aluminum oxide. Okay, that's why it's this boring white. Right, there's nothing in it except aluminum oxide. Do you use the dresser on non-diamond wheels? Okay, so do you use this dresser on non-diamond wheels? No. Okay, this is just about diamond wheels, and that's just aluminum oxide. It's now 10EE asks a question and then says it's really just for grinding the binder. It does grind the binder, but that's not what it's for, and I'll explain that in a second. After you do this, okay? After you do this, you end up with a pretty level surface, which is diamonds and resin. So think of it as you go out to your muddy driveway, and you take a scree or a squeegee or something, and you level out your driveway. So the mud and the stones are all about the same level. That's kind of what you end up with at this point. You're not ready to grind yet. Okay? Now you take what's called a dressing stick. And by the way, if you noticed that the dressing stick is boring white and this is it's just aluminum oxide, but it's in a very friable condition. It's very easy. It's very soft. You now, again, at regular grinding speed, we haven't even touched the speed of the wheel. Full grinding speed, 3,600 RPM. You jam with coolant at this point is best. You jam this dressing stick into the diamond wheel. And I know what you're thinking. You're saying, but Spence, you just told us that if you put aluminum oxide in a full-speed diamond wheel, diamonds aren't going to be affected. You're going to grind the aluminum oxide. Correct. Now your goal is removing some of the resin from around the diamonds. Okay? Different goal. The first thing we did, this thing, this is heavy. The first thing we did, this is truing. This is changing the shape of the wheel to be concentric with our spindle. This is truing. It's removing material. This is dressing. Dressing is preparing it to grind. We're removing some of the resin from around the diamonds, and now the diamonds are sticking out. The rocks are sticking out of the mud, okay? And this is also misunderstood. So I've seen videos, you know, when I was studying this over the years, you see people take a dressing stick and they go boop, boop, and they're done. And I'm like, okay, that's what I'll do. So I got my dressing stick and I did the thing with the brake dresser, and I went in and went, and 10EE, you asked a very good question. We'll get to that. Don't let me not get to that. So then I found a video, and you can find it online, from Norton from the 70s. It had to be from the 70s. And it showed a guy preparing a resin bond diamond wheel, you know, and preparing it to grind. So they true it, and then he says, and now you're going to take your dressing stick and dress the wheel, and you should use lots of coolant to keep the dust down. And they got coolant blasting on it, and the guy takes the stick and he sticks it in the wheel and goes, and he says you should use between 2/3 and 3/4 of a stick to dress the wheel. And I'm like, okay, dude. I got it. And the point was well made, because after you true the wheel with the brake dresser, and you take out your Mark IV Mod 5 sensory system here, right? And you feel the wheel, it's wicked smooth. Okay? Says the guy selling dressing sticks. Yeah, I know. That was not lost on me, but you could feel that the wheel is super smooth. And then after you dress it, the wheel becomes kind of like sandpaper, and that's your sensors picking up on the diamonds now sticking out of the mud. And by the way, these things are cheap. In fact, there might be other uses for these, but they're not expensive, so I don't get whipped up about that. So anyway, I changed my attitude toward dressing and using the dressing sticks, and I use them. And I'm not sure I quite achieve the 2/3 of a stick, but you just use them up, and that's an important thing to get used to. Again, toilet paper, use it up. That's why toilet paper is white also. No, really. Okay, so I've just walked you through taking a resin bond diamond wheel out of its box, mounting it on the hub, balancing it, which we're not going to get into in depth today. Oh, you found it? So what year is it from? So I'm afraid that if you're in the chat right now, you'll see the comment, but if you're not in the chat, you're not going to see the comment. So I'll tell you what, I will try to post the link to that video on something. I'll post it on Instagram and make it available to everybody. But you probably found the one. What year is it from? See if you can figure out what year it's from, because it was just classic. After you finish this process, you've trued the wheel, you've dressed the wheel, you're ready to grind. Now, should you balance the wheel now? And the answer is maybe. I like to, if your spindle's good, your spindle taper's good, if everything's good, you can balance it and put it back on, everything's great. 10EE says that video, hey Unix Carbide, 10EE says that video, he found it was 1987. So it's not as old as I thought. I'm older than I thought. That's the problem. All right. Now, I'm going to teach you one other thing, and I'm going to quit on diamond wheels unless you beg me to continue. The ratio that this diameter gets used up versus this diameter getting used up is called the dressing efficiency. All right? It's called the dressing efficiency. And it's not that good. Okay, that's why these wheels on the dresser get used up, because you're trying to make a thousandth of an inch change in the diameter of this wheel, and you're using up your $3 dressing wheel to get that done. So you could intuitively you could see that the dressing efficiency is pretty low. So this led to a dude named, I'm going to forget the name now. Shoot. I can't come up with it. But anyway, I talked about this patent in one of my posts, and I've talked about it multiple times. He patented the use of molybdenum, which is an element and a metal, and there's molybdenum right there in the middle, for truing diamond wheels. Now that method is pretty cool, and he claims a high efficiency in his dressing ratio. So molybdenum is pretty wicked cool. That's not the name on the patent, Adam. It's a W. It's a short name. I don't want to get it wrong. Shoot. Anyway, we'll post it. But molybdenum, okay, which is a pretty boring looking metal. If you looked at it, you'd think you're looking at a piece of steel. But molybdenum and diamonds had a very interesting relationship in that at a magic speed, which in this case is about 700 surface feet per minute, so it's very slow. At a magic speed, the molybdenum is to diamonds as mud is to galoshes. Okay? So if you try to walk through mud, you can walk through mud and your galoshes, you can pull your galoshes out of the mud and everything's cool. If you try to run like a sprinter through mud, you run through the mud. You don't have time to sink in. But somewhere in the middle is this magic speed where if you kind of walk through the mud at sort of a normal walking pace, the mud may suck your boot off your foot because of the suction. And that's what happens with diamonds and molybdenum. You get the speed right, and it will suck the diamonds out of the matrix. And this was correctly identified as a useful way to true a diamond wheel. So this is what I do to true my diamond wheels, is I use molybdenum. Now, this is a little fancy holder that I made, but you could easily take a piece of molybdenum and hold it in a grinding vise, and you're done, right? So why doesn't everybody do this? And why did he get a patent in 1973, I think? I think it was 73. It starts with a W. It's going to bug me until I find out. Okay. Good question. Do me a favor, 10EE, put that in the question button, because that'll hold it and I won't lose it. So why doesn't everybody use molybdenum? Now this gets back to another question that 10EE I think asked. He said, "Do you do this at full wheel speed?" And the answer with respect to the Norton is yes. You do this at full wheel speed because this device will lower the effective surface feet per minute. In the old days, we didn't have VFDs. In the old days, we didn't have a way to control the motor speed on motors at all, right? So if you walked up to a grinder and it was it's running on 3-phase, and you turned it on, it went from 0 to 3,600 RPM like right now, and that was your speed. So this device was to fix that problem and allow you to get a slower surface feet per minute because you don't have control over your motor. So that's why this thing looks like it's been around since the dawn of time, and that's because it's been around since the dawn of time. This is old. So if you could walk up to your grinder and say, "Hey, I'm dressing now, so I want you to slow down." Today, it's like I have a button on the Okamoto. I have 2 buttons to turn on the motor. One says grind, one says dress. So you can go to a different speed with a VFD, no problem. So today, if I go to dress my wheel, I go to my dressing speed, which is 1200 RPM for a 7-inch wheel, and I use my molybdenum, and I've done the math, and that's 700 surface feet per minute, and I'm ready to go. Now, how do we know that this is true? Let's see if I can find my little experiment. Crash. Oh, here they are. I'm going to show you guys something cool that I've never shown in public before. But this is a card of diamonds, just diamond, or I shouldn't say diamonds, of dust that I captured off of my chuck when I used my molybdenum, okay, on my diamond wheel at 3,600, this is going to be mirrored, right? 3,600 RPM, 2,000ths down, 2,000ths down feed, all right? And then you can see I captured some stuff. Now, I put this under the microscope and I looked at it. And maybe there's a couple of diamonds in there, and there's a bunch of molybdenum dust. So here's another card, all right? This is 1,200 RPM on the wheel, 2,000ths down, and it looks like there's a lot more schmutz there, right? And I put this under the microscope, and what did I see? A bunch of diamonds. So slowing this guy down to 1,200 RPM made the molybdenum more like mud to the diamond wheel's galoshes. And it started sucking diamonds off. And I measured 75% dressing efficiency. That means if I came down 2,000ths of an inch, I got 1.5 thousandths of an inch dressed off the wheel. Now, if you haven't done a lot with diamond wheels, that might not get you excited. I got really excited because dressing a diamond wheel takes a long time because of this efficiency issue. So there's your proof, measured, observed, scientific, sort of, that the molybdenum method works. And there it is. So one of the things I considered putting in my store is molybdenum dressing sticks. Oh, you're welcome, 10EE. Is molybdenum dressing sticks, and maybe even a little holder. And if you guys tell me, that that's a useful thing, I'll put it in the store. But I have a list of things I'm trying to get done first. But that's the story. Okay. So question: how do you know that you're doing a good job with the molybdenum if speed is so important? I think I answered that question scientifically. From a research point of view, this is how you do it. Of course, you're not going to do this every time you use this thing. That's stupid. But this just confirmed that the surface feet per minute is the right surface feet per minute. So then, if you're on the job and you just dressed your wheel, how do you know that you're doing a good job? So let me grab another prop. I'll be right back. All right. So this right here is a it's a Noga magnet base. It's a inter-rapid tenths reading indicator, and it's a piece of steel shim stock and the indicator. So I learned this trick from Robin Renzetti. Put a couple little tiny, style points of my own on it, but basically you can run this on your diamond wheel and check concentricity to a very high level of precision using this. So after you've dressed the wheel, you could run, put this on the wheel unpowered. You're just using your finger to turn the wheel around, and you could watch what happens with your indicator, and that's a really cool way to do it. And then when you wear out your shim stock, you can see some marks on my shim stock there. There we go. Okay, when you wear through your shim stock, you can throw it out and do it again. Please don't do this on your diamond point, or you're going to be buying. I'm not diamond point. Your indicator point. You're going to be buying more indicator points. This is a piece of white electrical tape, and I take a piece of shim stock and I cut a little narrow section to match sort of the dovetail here, and I just tape it on, and it behaves really nicely. That was my contribution to the universe, which is not much of a contribution. Okay, so that's one thing you can do. What else can you do? You can also mark the... Yeah, I know. I got different colors for different applications. The other thing you can do is take a pencil or a Sharpie. I think I like the pencil better for this. And I am not working for DMG Moore. Take a pencil and run it across the face of your wheel, okay? And then as you true your wheel, you should make the pencil go away. It's like every other time a metal worker uses a pencil, is you're doing it so you can see the pencil line go away. That works too. Gosh, it's 1:03. So I don't know. Did I kill that? Any questions? So if you have questions on this whole diamond wheel dressing process, let me know. So while you're doing that, I will add this comment. I was wearing out resin bond wheels. Oh, thank you, Adam. Nice feedback. I was wearing out resin bond wheels making PFG stones. Chuck says he enjoyed watching, but I made it harder to get something done in the shop. If I made it harder to get something done in the shop, I'm doing my job. I was wearing out resin bond wheels, and I went to metal bond wheels because I had a brilliant idea all on my own. Because Robin Renzetti smacked me upside the head and said, you really need to use metal bond wheels. So the metal bond wheels, roger that, 10EE. The metal bond wheels are stronger. So instead of a resin holding the diamonds, you have I think it's a nickel plating, or it's not clear to me what the alloy is, but you have metal holding the diamonds. Makes for a tougher wheel, and that's actually the right word, tougher. It also makes for a tougher time when you write the check, because this guy from McMaster Car, and you could check me on this, I want to say this is $120 for this wheel. By the way, this is like an $8 wheel, right? A regular aluminum oxide grinding wheel is like $30 to $50, depending on how fancy they are. This is $120, and a metal bond wheel, the ones I use for grinding the PFG stones, is $500. So, for me, it was absolutely worth it, and it has been totally worth it. But if you're just starting to play, it could get a little pricey. So that's there's economics involved with everything. 10EE says, yeah, I know. It hurt. But I'll tell you what didn't hurt. So after using that metal bond wheel and for as long as I did, I bought a second one. It's in my drawer, unused, $500 unused, sitting in my drawer, because going down because something happened is more expensive to me than the $500 spare tire sitting in the drawer. So everything's a trade-off. Hand it to my grandkids. Yeah, that one's lasting a long time. That one is doing a great job. But I dress it, we do the molybdenum trick, and we dress it every batch. So 10EE says, maybe sometime we could get a very detailed video of what you do at the Fanuc controller. So I'm going to aim, by the way, guys, just a heads up, program note, I'm going to aim for 115 to pull the plug, because this is going long. It's fun, but it's going long. So the Okamoto has a Fanuc controller, and the Sharp CNC has a Fanuc controller. So they're both Fanuc controllers, but they're very different. Very different in how I use them. So I can walk up to the Sharp CNC and start, banging in G-code with my G-code finger, and I could spend the day without touching a computer. And I'm, you're definitely talking to the controller, right? The Okamoto has a Fanuc controller, and so far, I'll qualify this in a second, I can do everything I need to do in their software, which is a layer on top of the Fanuc controller. It's all colorful and pretty. I'm into their full auto mode, which I don't know if you mean just on the Okamoto side, but for doing things like, I showed a quick post of rotary grinding using my master grind and doing some pins. We wrote G-code. Oh, let me scratch that. I wrote G-code to do that grinding, and that had to be done at inside Fanuc land, and that was very comfortable to me because I'm used to doing it on the Sharp. But that was so far on the Okamoto. That was the only time I had to get down and dirty into the gray colored screens and start playing Okamoto. Start playing Fanuc. But for normal grinding, my normal flat grinding, I have been serviced very well by the extremely poorly translated software of Okamoto. All right, we got 6 minutes before I pull the plug. Any other questions, comments, bad jokes? I shouldn't have brought that up, because now you're going to expect a bad joke from me. I didn't prepare one for today. ¿Hay preguntas? Hola, México. ¿Hay preguntas? Nothing. I wonder how long this delay is. So I will report to you guys that absolutely no takers on the YouTube stream. So in fact, I'm going to kill it right now. Tech support, I'm killing the YouTube stream. All right. White wheel order information. Do you mean this little guy, or white wheel, regular grinding white wheels? Chuck, do you have one of these, Chuck? All right, so I'm going to hold this up. The wheel on your unit is a Norton. Oh, okay, I think I'm interpreting. Yeah, okay, gotcha. So this is the chuck. This is the wheel for the dresser. It's a Norton 38A. That's the wheel type. That's the material type. 60, that's the grit type. MVBE, that's actually the bond, and then there's a number, that's probably your order number. Oh, it's backwards. Don't worry about this. You don't need any of this information. It's in McMaster Car, okay? So you go to McMaster Car and you look up something like Norton wheels or something, and this is a 3-inch diameter wheel. I'm just double checking. It's a 1/2-inch hole. Yeah. 3-inch diameter wheel, 1/2-inch hole, 1 inch thick. Okay? 3 inches, 1 inch, 1/2-inch hole, 38A60. And Croteau is correct. I think it's very clear in there as the only one there. MSC shows them in Norton replacement for $26. I don't think you're gonna make me look it up. I don't think McMaster Car has it that expensive. I think it's cheaper. Let me see if I can do that for you. I'll pull it right out of my orders, so it'll be quicker. I know, this is like the most exciting stream activity you could possibly have. Let's see. Hang in there, everyone. Let's help Chuck out. Let's see. Chuck, I'm not finding it like real super quick. So I will take this as homework, and I will get you this information. Okay, brother? Yeah. $26 sounds like it's too much. That's why I'm saying what I'm saying. I'll find it for you. But they're not super expensive. I want to say I'm remembering like half that. No, I'll get it for you. Because having the right tool is, makes life a lot easier. Okay, we're coming up on our end here. Dressing other wheels. Oh, yeah. Okay, so let's talk about, I think you're using the term dressing precisely. So, let me put that up here. So, we all know about truing with a diamond nub on a regular aluminum oxide wheel. Okay, your run-of-the-mill bog standard grinding wheel. So we take our diamond nub and we run it across the bottom of the wheel and we think we're done. So that's truing. And now we're going to ask the question that you asked, which is, what about dressing? So dressing is leaving the surface the way you want it. And here's the really super cool thing. It's like you're being an artist with a brush. You could have a little fine tip brush, or you could use the same brush and make a broad stroke with it. You could change how you use the brush. Same thing, you could change how you use the diamond. It's super simple. If you go across the wheel, first of all, you got to decide how deep you're going to go in the wheel. So typically a 1/2 thousandth for 46 grit wheels is fine. So there's a data point. If you go across the wheel slowly, you're going to end up with a super fine, smooth finish, which actually might be detrimental to your grinding, because it might burn. Hey, there's Barzy. Welcome aboard, bud. Whereas if you take the same exact diamond and you scream across that wheel, you are going to leave almost like a screw thread on the wheel, which might be, for what you're doing, advantageous. Dude, I thought you were going to send me the razor. Bar Z is asked me if I lost my razor. I checked my FedEx deliveries every day. It's still not there. I don't know. So you can decide when you. And this is especially true with aluminum oxide wheels. You could decide for what you're doing, what kind of dress you want, and I use the term fast dress or slow dress. So a fast dress, also known as an open dress. Grandmaster Bob, I am going to assume that you're referring to the stubble in your comment. A slow dress might be for finishing, and a fast dress might be for roughing, depending on what you're doing. It depends on what you're doing. Here's a case where you got to be really careful about your dress, and that is when you're grinding a chuck. No offense, Chuck. When you're grinding a chuck, that aluminum oxide wheel can very easily get loaded up with the non-ferrous materials in your chuck. And frequently that absolutely wants a very fast dress. So one thing you can do is, if you have to true a wheel that's really out of true, you could do kind of slow passes, and then the last pass you can come down a half a thousandth and rip across that wheel and leave an intentionally, I'm going to say a word that might not be exactly correct, but an intentionally rough face on the wheel for handling something like a soft material. Okay? So in aluminum oxide wheels, and this, by the way, is a dressing wheel, but go back to the open dress. Okay. Yeah, so fast dress equals open dress. Slow dress equals not open dress. But I think Warren is unreasonably excited about the open dress. And I'm not going to comment on that. So you can get control over the dress you leave on the wheel and based on how fast you go across it. Does that help? Did that do it? KR Blodgett? No, actually it was a really good joke. And I was going about 50 miles an hour, so I didn't get it. Then I got it. All right. All right, guys, this was awesome. You're all awesome. Thanks for the questions. Thanks for being here. I got to get back to work because these stones aren't going to grind themselves. So if you don't have a set of PFG stones, what's wrong with you? Just go to pfg.gg and learn about stuff. All right, Warren, take care, buddy. Chuck says, yes. Chuck says 4397 Alpha 47. I say again, 4397 Alpha 47. $12.33 each at the McMaster car. So there you go, guys. That's this wheel. Grandmaster Bob says 22. And I have no idea what that means, but I respect it. 22 is I don't know what 22 meant. Are we 22 minutes after the hour? Hey, thanks, Chuck. Let me actually write that down and I'll post it somewhere so that we all have that information. $4,397 Alpha 47. Okay, so get ready on your screenshots. Okay, screenshot that. You could flip it around in your editing app. There you go. Okay, this is how the community helps each other. And if you guys are interested in molybdenum dressing devices, let me know, and we'll productize that. Or if you just want to have molybdenum sticks in the store, let me know. We could productize that. Still backwards, and you forgot to give me your account number. I did forget to give you my account number, didn't I? Thanks for noticing. PFG.GG. Get yourself some PFG stones. But not 6 inches this week, because 6 inches are almost done for this week. But if you actually snuck an order in for 4 inches, which is what these are, they actually would get in this week. That's all I got from Kinetic Precision. Thank you for joining, and we'll see you guys next week. Same bat time, same bat channel. The YouTube thing was kind of a bust, so we'll just do it here unless somebody says otherwise. Warren, one of those is yours. It's the first ones. Don't worry, we got you covered. All right, guys, have an awesome weekend. It's still raining in New Hampshire. Stay safe. Go have fun in the shop. We'll catch you later. You're welcome. Anything I got up here, you can have as long as I'm not using it. I think that's enough of a respectful delay for cutting off the video. See you guys.